Good evening, all. Today, we would like to have a basic definitions of the FEE first unit, fundamentals of electrical engineering, that too in the DC circuits. First, we will go with the definition of the current. We will also call it as a electric current represented with the letter I, which means that rate of flow of charge carriers is called current. So whenever we get a word rate of means whatever the quantity we are speaking about is getting varied with respect to the time period. So here the quantity I'm speaking about is a charge is getting varied with respect to the time period t. So current I equal to rate of flow of charge carriers Q by T. Its unit becomes coulombs per second, or we can also call it as ampere, amps, which will be measured using a ammeter. Now you could able to see here how the current flow is taking place, which means how the displacement of the charge carriers are being taking place in a conductor. Flow of charge carriers or rate of flow of charge carriers. Here the moment you could able to see in the slide. Next, we will go for the definition of the potential or electric potential or voltage or EMF, electromotive force. So definition for this is work done per unit charge, amount of work done for unit charge. It is represented with the letter V or E. So finally it becomes V equal to W by Q. Unit of W work done is joule. Unit of charge Q is coulomb. Joule per coulomb. Otherwise, we will also call it as volts, which will be measured with the help of a voltmeter. Next, we go for a definition for the work done, which equal to product of voltage, current, and time period. Unit of the work done becomes watt second. And next, electric power or power. So definition for the electric power or power, one thing we can call it as a product of voltage and current. Other thing, rate of work done is also called as power. So here also rate of work done means work done is the parameter getting varied with respect to the time period, W by T. Its unit becomes watts. Then energy. Before going to energy, power P we can also represent in three ways. P equal to product of V into I or V square by R or I square into R. Then energy. So the capacity to do the work done is called energy. Its a unit becomes watt second. Watt second. Or we can also call it as a joule will be its unit. 1 joule equal to 10 power 7 ergs. Then basic representation of a electric circuit consisting of the three parts here. One is energy storage element like a battery or voltage or potential. Other one, a load like a bulb, light bulb, or any other we can take like a sink, motor, anything. But here we have taken a bulb load through a means of a switch and connecting wires. That DC circuit or a basic electric circuit can be represented in different types: closed circuit, open circuit, short circuit, series circuit, parallel circuit. First one, if we want to see the closed circuit, you see through a potential or a battery, whatever the bulb load I have connected through with the help of current carrying conductor, phase, neutral, both are closed through a bulb. So this circuit we call as a closed circuit. Here, so through a applied potential or a battery, load bulb connected, but it is getting opened here. Phase is connected to the battery, neutral has got disconnected. In between the gap is appeared. The circuit is opened. So this example for the open circuit. Third one, short circuit. Through by means of energy or voltage or a battery V, so load is connected bulb with the help of phase neutral. But here the both phase neutral are shorted, closed together. They both are shorted, closed together. So this circuit becomes an example of a short circuit. And the series circuit. So when the connected loads, whatever we are taking about, all the three bulbs I have taken as a loads, all three are connected in series to each other with respect to the applied potential or battery V. So it becomes an example of a series circuit. Then coming to the parallel circuit. So here also I have taken three different bulb loads. So all the loads are connected in parallel to each other, which means that all the phases of the battery, all the phases of the bulbs are joined together and connected to the positive terminal of the battery, and all the neutrals of the loads are shorted together, joined together, and connected to the negative terminal of the battery. Becomes an example of a parallel circuit. So some of the representations of a DC circuits. So definition for the DC circuit is nothing but a closed path in which the direct current flows is called DC circuit. So default, you could able to see some of the simple DC circuits shown below with the help of a DC source or a battery and load like a lamp or a bulb through a switch and a current carrying conductors or connecting leads. Now, resistor. We will see some of the elements like resistor, inductor, capacitor. So resistor means it is an electrical property of resistor is represented with R. It is the property or the material due to which it opposes the flow of the current I. So that property we call it as a resistance represented with R only. Its unit becomes ohm. Some of the resistors you see here, they will be replicated in different means like this. And the moment when we speak about the resistor, we will speak about the specific resistance or resistivity also, which means that the resistance of a material depends on the nature of the material. Suppose if a unit length of the conductor having of area of the cross section A, then its specific resistance or resistivity rho becomes RA by L. So resistivity or specific resistance is represented with a letter rho become RA by L, where R is the resistance in ohm, A is the area of cross section, and L is the length of the conductor. Unit of the specific resistance or the resistivity becomes ohm meter. Then conductance is represented with the letter G. Reciprocal of resistance is called conductance. So unit of conductance becomes reciprocal of ohm. So it becomes mho or Siemens. So G equal to 1 by R. It becomes rho A by L. Then whenever we see conductance, then we need to speak about the conductivity sigma. So reciprocal of the resistivity is called conductivity. Its unit is a Siemens meter. Its unit is a Siemens meter. Sigma equal to 1 by rho, because reciprocal of specific resistance or resistivity. So sigma equal to 1 by rho. Its unit is a Siemens meter. Here, a small numerical has been given. See here, length and area of wire are given as 0.2 meter and 0.5 meter square respectively. The resistance of that wire is 3 ohm. Then calculate the resistivity. Directly substituting in the formula, resistivity equal to rho equal to RA by L. So given parameter substituted as it is. R is 3 ohm. Area is 0.5 meter square. And length of the conductor is 0.2 meters. So after substituting the final value, 7.5 ohm meter resistivity is obtained about. Then inductor. A wounded coil, we call it as a inductor. It has a property called inductance. It is represented with a letter L, and where it stores the part of applied energy in the form of a magnetic field, E equal to half Li square joules. Its unit is being measured in Henry, and a symbol is represented likewise, a wounded coil. Some of the indicators, representations for the inductors will be shown here. Different types of inductors we use in the circuits and in other applications are represented here. Capacitor is a device. It has a property like a capacitance, due to which it stores a part of applied energy in the form of an electric field. Its unit is measured in farad F. So symbol of the capacitor, you could able to see two parallel plates. And here some of the capacitors you could able to see here that we use in the circuits, and some other our applications based on the requirement. It is being made up of a ceramic or electrolyte material, and energy stored in the capacitance in the form of an electric field E equal to half CV square joule. Thank you. Rest of the topics we will see in the next session.